Hello everyone. In the previous video, I have explained that explained about the basic modules like part, properties, how to define properties and assign properties, and also assembly part. So now in this video, I will try to explain how to do the machine interaction. The most important part is step and loading. So in this video, there's four main modules I will be explaining. So let's start with the machine part. So go to mesh and then there are two options, assembly and part. So you have to select the part. You see there are two parts, pile and soil. So first select the pile, see part. First you should give it a trial that how much closely spaced seeds are coming with this point 0.95 value. Just check, just clicking on apply. So if we want more denser, then should reduce this value. 0.8. We want denser than this. Now it looks fine. It's okay. So since it is a symmetric structure, so symmetric part, so we can directly give it a local global seeds. This is global seed, and this option is local seed. So here global seed is enough. Local seeds are not required. So then go to the create mesh. Yes, the mesh is created. Next we will go to soil. So the soil part is a bit complicated. Here you need to apply both global and local seeds. So first we will create mesh on the XY direction. So XZ direction. This is local seed. In global seed, you can't like uh, modify the things on your own. The whole model will be the seeds will be distributed homogeneously. But in local seeds, you can just wherever you want to put more number of seeds or the more denser seeds or more denser maize. So you can apply on your own. Customize more customization can be possible in local using local seeds. So that's why we are selecting local seeds in soil. But so just select this one, shift, select this one. So the direction should be towards the pile. That means the denser part image will be more dense towards the pile from the boundary side. And if this is the default value, the minimum size, that means near the pile area, the mesh size will be denser, more closely spaced, and towards the boundary, the space will be more. So that's why it is maximum size. This is the minimum size. So just we need to change the direction because this direction is not towards the pile, but this direction is towards the pile. So we need to change these directions. This direction is changed. Now we can apply this. So now we will select in this direction. In this direction, we will again select as in up to this depth as the pile is there. That's why we will try to keep the homogeneous machine. That's why it will be my number none with some denser one. because the pile is there. So the analysis should be more precise. The more accuracy we need. Now select the bottom one. Direction again. So some another lines are being selected. So for that, we have to click on this. Let's check this. Fine. Now go to by size, single, change the direction. Uh, Now we will go to the YZ direction. This direction, what we will do, then we need to select this one. Direction we need to change. The same minimum and maximum sizes. So next, go to XY first. Now we have to apply some global sheets because some middle portions, some middle areas, there are no sheets. So those areas will consider as global sheet areas. So try to keep it as lesser as possible because these global sheets will be considered in these areas, the main vital areas. Can show you. So I can show you if I keep it 1.1. So how the values. Now you can only see the seeds. Okay. Now just go to the assignments controls. Check the whole area. So, yeah. This will give you additional accuracy for the shell area. This is the shell area, so it's a pile area. So now you can check the mesh. See, so now the mesh is coming like this. This is coming like this. Means you have to increase the density in this area. That means you have to reduce the value of global sheets. Let's see. Let's make it 0.5. Apply. So during application, they will ask for deleting the mesh because when they will reduce the sheet spacing, that time again they have to produce some extra sheets. For that, they will have to delete the meshing. So delete mesh. That way. Okay. Now just again delete mesh. Now we check this person is getting denser than the earlier. Check. Whole area. It's fine. During applying local sheets, You can also just reduce the minimum values of these areas, like while selecting the local cells. It's fine, it looks fine. You can also check if the machine is correct or not by clicking on this option. Just clicking on this option and just select this area. Done. You can see if there is any error, then they will show with this color, and if there is any warning, they will show in this yellow color. So let's highlight. So let's see, there are total number of elements is 82,496. Analysis errors is 0, analysis warnings is also 0. Missing is fine. Now you have merged separately. Now just click on the assembly. The whole thing will come. You can also see the file, also see the file. So this is all about meshing. Also, you can modify meshing. There are so many different methods. This is the basic method. You can also refine the meshes, but that is not required in basic stage. Next, we will go to interaction. This is one of the most important part. And here, basically, one interaction will be there. That is soil and the pile, between the soil and the pile. So create interaction property. Just make a soil contact component on the mechanical potential there. And then based on the friction coefficient given in the journal you are referring, just simply I am considering 0.5. Okay. So in this, clicking on this option, it will find the contact pairs. Just find contact pairs. So it has already found the contact pair, that is soil and pile. Okay. So now we will check here that interaction is created from the initial. Now you can see here, edit, clicking on edit. So it is what it is showing, master surface and slave surface. What is master surface and what is slave surface? We need to understand here. Master surface means the surface. So there, why we are creating interface or interaction property? Why we are giving here? Because there are two different types of material there. Two different types of materials. So always master surface will be that surface which is having higher stiffness. So here pile is stiffer than the soil. So the pile should be the master surface and soil should be the slave surface. So we need to interchange. Just click on this. And also check it. If it is wrong, so you have to interchange the surface. So now master surface is pile and slave surface is soil. Now it's fine. Okay. So interaction is done. Next is step module. This is the most important module. In the step module, first you have to create some boundary conditions. Before that, you have to finalize the stages of the analysis in this case. So this is initial, this is default. Automatically it will come in every analysis. After that, after this stage, you have to create. So next stage will be geostresses. And it will be just select static general. It will basically consider the self weights of the parts, different parts. Static general. Just keep the default values. Fine. Next, I am considering in this video as dynamic loading. So for that, dynamic implicit should be selected. case is space is not considered. Suppose implementation is great. Fine, looks fine. Just time period I am taking as suppose it is 5 seconds. So this is the total time period of dynamic loading, whatever I will be going to apply. Now, dismiss. After that, this is the field output manager. So automatically it is created in the geostrace mode, and it will be automatically propagated in the next. That means the values that the outputs we will be getting in the geostrace stage, the same values also, the same outputs, the same parameters also will be calculated in the dynamic stage. But if we want to get some additional parameters in dynamic stage, then again we need to create. Suppose we need some acceleration time response, velocity time response in the dynamic stage. So we need to give some additional output for that. So in dynamic stage, we want to continue. So in dynamic stage, this is dynamic step procedure, dynamic implicit. So in this stage, as it is mentioned in the time period, so every x units of time, every x units of time. So x, what will be the x value? So x value will be depending upon the frequency of the dynamic load and in which time intervals you want to get the results of that particular parameters. Suppose if your dynamic load is a sinusoidal load and the frequency is 1 second, sorry, frequency is 1 hertz. That means 1 cycle per second. That means the dynamic load cycle, like 1 cycle will be completed in every second. That means in every cycle, there will be a positive peak and there will be another negative peak. So if we want the parameter values, suppose we want some acceleration versus time. So that dynamic plot, uh, let's let me show you. Is the so this is, if this is 1 second, this is 0. So if we want some acceleration time response, so the software will give you acceleration values in which time intervals. So generally we use this time interval. You go to this. So basically this time interval is divided into 3 equal parts. That means 1 by 3. You get this because the frequency is 1. That's why. If the frequency is changed, then this value will also change automatically. Got right? So this will be 0. And now you can select some basic things like stresses, strains. You can select total strain components, plastic strains, equivalent plastic strains, displacement mode, translations and rotations, also accelerations, forces, direction forces, and movements, direction movements, section forces and movements, concentrated forces and movements, In contact, simply just context traces. So these outputs will be enough. Now click on OK. So now output is created on dynamic stage only. Before some output were created in geostraces, and that thing also will be calculated in dynamic mode. But it's coming from geostrace part. Some extra parameters I need to calculate that will be selected in dynamic. Okay. Selected in dynamic stage only. Those parameters will only be calculated from the dynamic stage. So here, state module, just have done two things. One is finalizing the stages, and second thing is creating the outputs. Next thing is load. The loading stage, first we need to define the boundary conditions. Boundary condition is most important in case of so any kind of analysis. Yet first we will see there are three boundary basically. X, this is xz, that is yz, and that is and then bottom boundary. So this one is X. So I will consider as xz, that means this space xl displacement rotation continue. This spaces inference spaces. This was fifth. And also options. Then let's check the selection if it is fine or not. Yeah, it's fine. Step. Create a scene. Done. So just we will fix the U1 boundary. That means the displacement in x direction is fixed. So that's why U1 is clicked and it is 0. So now you can see that it is created in the dynamic stage, but it should be there from the initial stage only. So click on the created, move left. Done. Next is create the Y side. So again, need to select the Y face. So the faces are selected properly. Escape. Done. I think again it is selected in the dynamic. Okay, no problem. Click on move to okay. So should be move left. Fine. Now another one is the bottom boundary. Bottom boundary and click on the initial. Then here the dynamic was selected. That's why it was showing like this initial. Okay. So now displacement will continue. Surface, or else you just click on XY surface. Not XY, YX. YX. Right. So just select. During selection, you should be very serious because there are so many lines. May get confused sometimes. Down. One, two, three. All the boundaries should be fixed. All the direction information should be fixed in bottom. Okay. So now boundary condition is created. Let's check. Conditions are created properly. Okay. Top boundary is free. So now you have to create load. So first you will create file self load. File self load. It will be in the stress. Self weights will be there in stress. So gravity. You know. So gravity means you have to input the gravitational acceleration value. That is 10. For that you have to select the region. So as it is an assembly, it is very difficult to select the file only. For that, just go to view, stance, select on, we select the file. That's like, so only file is left over. Just click on this, select, done. Now look at so now you can check that the file gravity load is already active. Now, next one is the file with the soil. Apply. Next is for the soil part. For the soil part, you have to create some stress. That is that vertical stress due to the self weight of soil body, the ground surface will experience some vertical stress. Suppose the vertical stress gamma into z. That some gamma z will be at the top. At top z equal to 0, so gamma z equal to 0. At the bottom, some z value will be there, so gamma z value will be there. Could be from the initial stage, mechanical to static stage. Continue. So this is the top value, 0, 0. Stress magnitude here should be gamma z, right? So, so before that, we need to check the properties. Okay, that was 20, right? We need to check the properties. Forgot how much was okay, let's take the density of the soil was some minus. Minus is because of the z is towards the downward direction. That's why it is minus. So minus. Suppose it's 1700 something. So that is rho, the density to g. G is 10 into z value. Z value is 25. Vertical coordinate is 25. And lateral coefficient is that is supposing race condition. What is the coefficient of earth pressure, lateral earth pressure? That is 1 minus sine phi. So phi value is 20 here. So 1 minus sine 20. That is 0.66. 0.66. Done. So this is also been created. Now you can also activate the file apply. Okay. So now we will create the dynamic. The dynamic sketch. It will be suppose it is acting in the file top in lateral direction. Suppose concentrated force. Continue. So select points for the load. So suppose it is acting in the x direction. So if it's point, if you take this, the magnitude of the load is 10 Newton. I already explained about the units. So 10 Newton, suppose, or more than that, suppose 100 Newton. So yeah, this is a multiplier. You have to define the pattern of the load dynamically. So let's consider as sinusoidal. So sinusoidal comes under the periodic dynamic loading. Continue. So here you have to include the circular frequency. So as we consider the frequency as 1 hertz, so circular frequency will be 2 pi into frequency 2 pi f. So 2 into pi value is 3.1 into 1. Starting time will be 0. Like from 0, the magnitude will be increasing, and initial amplitude will be also 0. A and B. So A and B are constants, which like A is always 0 for sinusoidal, but if it is a cosine curve, then A value will be there. So A will be 0 for sinusoidal. A will be 1. Okay. So now the pattern is being defined. Okay. You can also check here amplitude plotter. This one. Actually, here dynamic load. Check plotter. Selected plot. So you can see that because it is giving 3 peaks. By default, it gives 3 peaks. But maximum x value, if you mention here that yeah, we want the plot for only 1 second. Let's see. See this. Only 1 second. For 1 second only you get the yeah. Okay. This is. So now you can see that the load is also being activated. The whole model is ready for the analysis. So it is acting towards this direction. Okay. So after that, just simply go to job. We just define create suppose um, response. So these things are default. You don't need to change. Here you can change based on your laptop capacity, based on your processors. You can increase so that the calculation times will be reduced. Okay. So after that, just simply check data, submit. So in the next video, I will try to show the after analysis what are the results coming, how to plot the graphs, how to get the exact outputs what you want. So hence, let's end this video here. So if you just like this video and if it is helpful for you, just follow the channel. If you have any doubts, just please comment below. Thanks for watching this video.